Hey, what's up, guys? This new tutorial is going to cover individual leaf randomization. I was looking into how to do this, and I put up a post about it in the Redshift Facebook group and also on my Patreon. And so a lot of people started asking me how I did this. And you can do this if you own, like, for example, SpeedTree or a tree generation app. You can actually export individual tree leaf groups. But let's say you bought this asset or you got it from someone else further down the pipe, and you don't have access to the generation of the tree. And so now you have one group of leaves, and you need to add some variations and break up this tree setup into multiple groups. And so, for example, right here we've got this yellowy leaf system with the overall green system. And so a lot of people ask me, okay, cool, how do I go about doing this? And so in our example, we've got the entire leaf system. So if we zoom out here, you've got the entire leaf system, but we also broke up into this little smaller percentage of leaves. And so basically, to do this, I needed to break up each individual leaf into its own primitive group and make sure that the leaf stuck together, and then split it up into a percentage that we could control and then make groups out of it. And so originally I was thinking, okay, I could just use a fit range and somehow figure that out from there. But what ended up happening is a fit range group SOP, basically each primitive wasn't together. So it would be like half would be one primitive group, and another half, or a piece of this, would be another primitive group, and that wasn't working. And so I'm going to go over how I did this so that you could have separate groups, so you could shade your leaves individually. And there's another thing I need to mention. Recently, the denoiser for optics for Redshift is now available. So as you can see, look how fast it cleaned up. It's pretty amazing. This is the noisy version, and if we look at the beauty, it's already cleaned up. And so this is now available for everybody to use if you're using the experimental builds. We also, Houdini recently got per light AOVs, which is awesome. I made a post about it for using Maya for my YouTube channel, and I put it up on the Patreon just so you can see what you can do with it. And it's basically the same principle. If you go under your Redshift ROP and you go into output and you go to AOV section, now you could add AOVs. So if you add an AOV, for example, and the AOV menu was updated recently, actually. Probably should have paused the IPR before making new AOVs. So yeah, I had to pause that. It looked like it crashed on me. So it might be due to how IPR now works with AOVs. So no IPR running right now. If I make an AOV, we've got this new AOV menu. You could do AOV setup, select the AOV you want. You can disable all AOVs for the entire scene if you don't want them. There's the grouping you can do by light groups. So here's the new light group setup. So you can do, if I don't have any light groups set up, but if you were to have them, you could list them here or just select all. Yeah, and so this is the new AOV system. And actually, let's make a few just so you could see that it's working now with live rendering. So if I do reflections, yeah, let's just do this. And so if I open up the IPR now, Let's do that real quick. And you'll notice as soon as it starts rendering, we have, even though this is progressive mode, let's actually move to the camera, and we move around, our AOVs now work in progressive mode. So this is great. You don't have to do bucket renders every single time now. So this is cool. So you can preview your AOVs now in progressive mode. We've got per light AOVs in Houdini now, and we've got the denoiser, which works pretty well for look dev especially. And so that said, okay, cool. So let's just kill that render and get back to what we were talking about. And so if we jump into this tree, we've got the breakup of leaves, and so we can control this using a couple setups. And so I'm going to go over how to do this on another tree, but pretty much to give you just a quick summary, we're using the connectivity SOP to put things together, and there's two methods to doing this. The attribute wrangle, I'll cover it, and we could also use an attribute VOP node setup, which does the exact same thing. And the reason why I'm doing it both these ways is because, like I said, I'm not a wrangling type of guy. I'm not, I don't like coding or anything like that, but I understand that it's important to learn this, so I've been trying to learn it myself more. And so I'll explain to you what's going on in this code, and we'll do the same thing visually using nodes inside of VOP, so you can learn both ways. And eventually this creates the attributes we need to then control our setup with group expression, which lets us control the leaf count by a percentage. And so right now it's at 20.2, which is basically 20% of leaves will be turned into this group right here that's highlighted. And so if I were to increase this to 0.7, we'll and hit enter, you'll notice that now this group has 70% of all our total leaves highlighted, and so a lot more obviously. And we could obviously do 0.5, and this will only do 5% of the leaves, and now it's only 5%. And so you doing this, and we can make multiple groups, lets you add a lot of variation. So you could have like 5 different shaders, one that's your overall color for your leaves, then you have maybe 50% of your leaves are a little different green, then maybe 20% are a little yellow, and then maybe only 5% look dull and dead or something. And so this lets you add a lot of variation. So as you can imagine, if you do this to your tree, and then when you're instancing, you also add variation to your overall colors using the either material style sheets or the user data system that I showed you guys, I think, in tutorial number 4. If you use that technique also, plus this technique, you'll get tons of variation for your forests and your foliage. And this technique will work with any tree system, really, or anything. It doesn't have to be trees. It could be just a bunch of boxes or something. And but you wouldn't really need it for that situation. This is more of you would use this for a situation where you got geometry from the outside like this. It's tons of assets that you can't individually randomly group up and select. And so okay, cool. Let's actually get to making this, and we'll try it out with a different tree. So let's hide this tree for now, and let's maybe try the acacia tree. Let's see, where did it show up? There it is. And so we'll test this setup that we did on the black gum tree, but we'll do this to this acacia tree we've got here. So in another tutorial, I think you guys saw me in one of my older plant shading tutorials, you saw how I went over and shade the the leaves and all that stuff. And so we're not going to cover that. We're going to cover how to break up the group of leaves. So right now, if you look at it, there's only two groups of leaves. So if we zoom in here, and you'll notice that we've got this group and we've got this group, which is cool. We've got two groups, but let's say we wanted another group of leaves. Let's say we wanted this group, but even less than this. So we wanted to generate a new group. And so in order to do this, we're going to apply the technique that we did, that I just showed you, to this whole setup. And so to start off, let's keep the transform and our material group. We'll move this way down here just to avoid it getting in the way. And actually, well, let's disable the transform for now. And so what we need to do is we need to first separate the this leaf system or this leaf group from all the other geometry. So in order to do that, we just right click here, start typing in blast. We'll build a blast node. And if you guys don't know already what blast does, it kind of just deletes everything. It gets rid of everything. And so up in the group section, the one we want, I believe, is leaf 2. So let's try leaf 2. And what it'll do is right now it's deleting the group we have selected. We want to do the opposite. We want to delete everything else except for that group. So you just click right here, delete non-selected, activate that. And so now everything else is deleted except for this group. And so several ways we could approach this. We could actually maybe try to add both of the groups. And so it's a small percentage of the total sum of the leaf shaders, but I'm not sure if the textures are different. So it might be better to just do one at a time. So I think we'll just stick to this, because I don't remember if the textures for the asset on leaf 1 and 2 are completely different, and so it wouldn't make sense to pipe them both in. But anyways, okay, so now we've isolated our leaf system that we want to work on. And so what you could do is make a merge, and we could basically just merge this back in so that we got all our other stuff basically here. So if I do this, duplicate this blast, and I uncheck delete non-selected, we'll get the rest of our tree back. And so we bring this back in, bring this back in, and bring this back in. And so what we get is we put together our tree setup so that our individual leaves and our rest of our tree come back together in this group and come back just like nothing happened. And so this lets us keep our tree together, but we can work on the individual leaves on their own. And so, okay, cool. So now we've got this set up. Let's move this to the side, and let's move this down the middle. And actually, let's just get rid of that. And okay, so our first step here is we need to make each of these leaves an individual group. So right now, if we were to select them, they're just a big group of leaves. This counts as one giant group. And so that's not what we want. What we want is each leaf to represent an individual group. And so in order to do that, there's actually this really neat SOP. So if you right click or hit tab, start typing connectivity, you'll get the connectivity SOP. So we'll drop that down here. And so this creates an attribute and you want how you want things to be connected. And so we want the primitives to actually be what's connected. And so we're going to change the connectivity type from points to primitive. And the attribute, the default is class. You can name this whatever. We're going to just keep it default. And so if we check our geometry spreadsheet, or let's just open a new window since we're gonna be looking at the geometry spreadsheet quite a bit. And so we've got this new window. Let's switch on over to geometry spreadsheet. And we'll just keep this open. So if we select actually our, from this point, our connectivity, and instead of using points, we move over to primitives, we should have the attributes show up that we just created. So under connectivity, if we check out our attribute spreadsheet and we're under primitives, we'll notice we have our groups, and we also have something here called class. And so this is a list of all the leaves that we have. And so what you want to do is we want to check how many individual leaves we have. So we've got 78,152, a lot. And so this number is important. We'll need this number later. And so now that if we let's move that out of the way. We looked at all our objects as individual. Each little leaf is its individual class attribute. What we can do next is now we got to be able to bring all 78,000 into a smaller range that we can then randomly select from. And so this is where things get a little more complicated. We could do it two ways, like I showed. There's the attribute wrangle method, and then there's the attribute VOP. And so we'll do the attribute wrangle first, just because I think it's a little more complicated, but it'll make sense once you see it through the attribute VOPs, like what nodes are doing what. It'll make more sense of the equation. So if we right click and start typing wrangle, we'll get the attribute wrangle. We'll drop this in. Let's highlight up to it. And so right now we want the wrangle to run over primitives, not points, because each leaf is a primitive group is what we want. So this little cluster, as you can see, is a primitive group. It's a group of little primitives. And so now what we need to do is, what we want is integers to choose randomly from, because we don't want each leaf. There's no 1.5 whatever of a leaf. There's leaf 1, leaf 2, leaf 3. They're full numbers. They're integers. So our first step in the wrangle is to type in an I, which is integer, and then use the at symbol, and that means integer attribute. That's basically what those two things mean right there. And then we're going to give it a name. So we could call this whatever we want. We'll call this, let's just call this leaves. And so now what this means is this is an attribute that we've just created, an integer attribute called leaves. and this is equal to, so how is this attribute being created? And so what we're getting this data from is from our class. So we're going to convert all these 78,000 whatever numbers into something that we could use to control our leaves. 0 through 100 I think is better, because then you could think of it as percentages, 0 through 100%. And so from here we're going to type, you got to think of this also as an equation. So order of operations matters. So first what we're going to do is we have our integer at class. And so what this is connecting to is this, integers, and the attribute is class, which is what we made earlier using connectivity. This created this attribute for us. Okay, so now we've got that. And what we want to do is we want to multiply this by our maximum number of individual objects. So what we're going to do is we're going to multiply this by 78,152 for our example. And so then we're going to now put this inside of parentheses. And the reason is because this is order of operations. So we want this to happen first. We want integer attribute class to be multiplied by the total number of leaves that we have. So that's first. That's step one. And now what we want to do is we're going to type in rand, which is random. Oops. And so rand means it's going to select a random number from this. And so what we want is now we want this random to be between integer class multiplied by 78,152, 0, and 100. And the reason we want 100 is because we want this to fit between 0 and 100, basically. And so now we're going to add another parentheses here and another parentheses here, so that this is step 2. After this gets multiplied, step 2 is randomly select this number between this number and 0 to 100. And then the next step is we're going to make this fit between 0 to 1. And what fit does is it basically takes this number and compresses it down into a 0 to 1. And then after that, we're going to add another parentheses at the end, because this is the third step. And we'll add another one here. And finally, all we write is int, because we want all this to give us an integer, and a semicolon at the end. And so now what we should be getting is this is going to create a new attribute called leaves. That's an integer based on the attribute we created, class, between the numbers, fitting it between 0 to 100. And so if we go to our geometry spreadsheet, we should, let's see, hold on a second. Okay, we've got, class and leaves. So why is it not updated here? Ah, there we go. I don't know why it's not, it's because it's not pinned. It was pinned, so it didn't update. So now we've got class, which gave us a group, or not a group, but an attribute for every single leaf primitive clump, and we turned that attribute into 0 through 100. So now we've got 70, 50. As you can see in the leaf section, we've got tons of numbers, but they aren't individual now. They're 0 through 100, randomly selected. So that we have 56, 32, 48, 53, 79, 95, 20, and so on. And so it's randomly selecting 0 through 100 integers, so they're not floats. That's why none of these numbers are 95.5 whatever. No, it's just pure integers. And it created this new integer attribute called leaves, because this is what we wanted. So it turned this attribute, and it randomly selected from class and compressed it down. It fit it into 0 to 100. And so now we have this set of attributes. And so now using that, we can now right click and type in group, and we have group expression. And so what a group expression lets you do, and let's move this down a little bit. Let's actually move this that way. And so let's highlight the group expression. And so now, where it says vex expression, we could actually, luckily for us, we don't even have to come up with it. Houdini comes with a preset, so you can just click on this little arrow, and there's one called 30% chance. So let's just select that. And so what this does is giving us a 30% chance selection of an attribute. So right now, the attribute that it comes with is alemnum. We don't want to use that. We want to use the one we just created, which was leaves. And so now if we type in leaves and we hit enter, it's going to create a new group called group 1, and it's going to randomly select from the let's get rid of that E, the leaves attribute, anything low, basically anything greater than 0.3 will not be selected. So anything lower than 0.3 is selected. And so basically 30%, because 0.3 is 30% of 0 to 1. And so now we have this new group called group 1. And so now if we check our group list, we'll see that we've got group 1 here. And that group 1 is equal to 30% of all our leaves. And so we can make this number smaller. We can make this 0.5. And now it's only going to select 5% of all our leaves. And so you can name this group whatever you want now. So you could call this leaves 5%. And so now we've got this new group called leaves 5%. And so you can now do the same thing. You could duplicate this. We could call this leaves 25%. And we'll just copy this, paste it there, and type in 25, hit enter, and now we've got another group. This is group leaves 25%. And so what this lets you do is now we have group clusters based on percentages that we've created. And so now we can assign materials based on groups that now will show up here. So you'll see that we have now, if we go through this list, we have leaves 5%, leaves 25%, and so on. And so this lets you now apply materials based on the groups we've created. So you can create as many groups as you want. So you could, like I said, we could have a group that's only 25%, 5%, 1% if you want. So let's actually do that. Let's copy that. Let's paste that. We'll make this 1%. And now we have this group of leaves, which is only 1% of all the leaves that we have. And maybe that's still too much. Maybe we want less than that. It's 0, 0, 5. And now that's only that group. Only a few of them. And so we'll just keep it at 1. And yeah. So this lets you control your leaf groups by percentages. And so this is the method using the attribute wrangle, which again, this is a little more complicated than usual stuff I've been showing you guys, since this is more yeah, it's Vex, and I know a lot of people hate Vex, and a lot of people hate Houdini tutorials because they just dive right into Vex, and you don't know what's going on if you don't know any of Vex. And so the next technique I'll show you guys is creating this same thing, but we're going to use nodes with attribute VOPs. So let's start off by making a attribute, or let's just type in VOP, and we'll get an attribute VOP. And so we'll move this to the side, and we'll move it down here next to our attribute wrangle. And so instead, we'll have our connectivity plug in here. And so now we've got our attribute VOP, and we'll come into this. We'll go this way now instead of this way. And we could actually duplicate this, and since we're gonna call it the same thing, but we'll get to that right now. And so what we need to do now is we need to create this using an attribute VOP. So the first step is we need it to run over, just like we did with the Wrangler. We need it to run over primitives, not points. So we're going to switch over to primitives. And what we need to do is if you hold Alt-E, you'll pop up while you're inside one of these coding windows, one of these Vex windows. If you just hold Alt and press E, you'll pop up this window. And this lets you type in the Vex or keep this window open on the side, so that way we know the attributes we're using. So we'll just keep this window open on the side, and we'll dive right in. And so if we look at our geometry spreadsheet, we now don't have our since we're on this side of the node tree, we don't have our leaves anymore. Like if we did over here, we have leaves. So we're back to this side, and so now we're starting over, like if we didn't do this. And so let's move this out of the way for now, and we're going to dive right in. And so we've got these two nodes. We don't really need them. We're going to be doing stuff with binds. And so if you hit tab, type in bind, you'll get the bind node. So what the bind node does is it lets you normally you start with these basic attributes, but since we created a new attribute called class, we're going to bring it in. So, and if you're wondering where we got class, to go back, we got it from this connectivity created class. So inside of here, we need to bring in class. So this is going to bind class into this node and bring it in. And so class when we created it, isn't a float. It was an integer. So we're going to change to integer now. And so to see what's going on, let's keep our geometry spreadsheet open. And we actually want to write out another bind. So we're going to type in bind. And this is bind export. And so what we want to export, this new parameter, we're going to call it leafs, since that's what we called it earlier. And this one we want to be also an integer. So let me save. And so if you were to think of it, here's the Wrangler we wrote. Basically what this is this integer class, and our output is leafs integer, which is this, equal to. And so what we got to do is do the math in between A and B, to connect it and output correctly. And so if I let's see if I just connect it directly. If I just connect it directly right now, you'll see that we have leafs. It just created the leafs column. But the problem is that leafs is just this to this. That's why it's the same numbers. So what we need to do is we need to do the math in between. So step 1, which we have here, was class was multiplied by this number, 78,152. And so that's the first step. We need to build a node to multiply our class input. So again, keeping in mind order of operations, this is the first step because it's in parentheses. So if we hit tab, let's move this to the side a little. Hit tab, start typing multiply. You'll get a couple multiply options. What we want is multiply constant. And so we'll just plug this in. And we want this to be an integer. It automatically knows to be an integer because this is an integer. And so the number we're multiplying by is this. And so now we're going to get a huge number on our leafs column. So then the next step is we need to randomly select these numbers, because here's the rand, and this is the next stage of the brackets. And so what we're going to do is right click, start typing rand, and you'll get the random node. And so we just want, I think it automatically selects it because it already knows that this is an integer. Because this is an integer, it automatically chooses 1D integer float. So that's fine. That's what we need. And so now if you look at our leaves column, it's randomly making numbers, but now the numbers are 0 to 1. So it's 0 point blah blah blah. They're floats. And we don't want floats. We want full numbers. And so the next step is, as you can see, now that it's randomly making numbers, we need it to be 0 through 100. So we're going to multiply. So let's create another multiply constant. And this multiply constant, we're going to make this 100. And so now we've got leafs 61 point whatever, 71, 45. We've got all these numbers, 90 something. We've got 0 through 100, but they're floats. So they're 61 point blah 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 blah. We don't want that. We want full numbers. So if we were to change this, we can't change this to integer. So what we have to do is right click again, and we're going to type in float, and you'll get this option to make a float to an integer. So now if we make this, they're full numbers. So 61, 71, 45, 48. And now it's 0 through 100, like we had here, using integers based on random selections from our class attribute that we created in the beginning. And so now, basically this is going to be output to leafs as an integer. And so what this node setup did is basically do the same thing as this, except this is code. If you know how to write this, this is probably, it's faster. You know, you can just type it. But this lets you see what's going on in order of operations. And so, okay, cool. And so now if we go back up, and if we could just duplicate this, or we'll just make a new one and type in group expression, highlight this, and we'll use 30% chance again and delete this attribute because it's using elemnum, and that's not what we want. We want it to use the new attribute we created, leafs, and we hit enter. We'll have the same thing going on. So now if we look at our groups, we have group 1, which is this one we just created, and now it's 30% of our leaves are selected. And you could see it actually in our attribute spreadsheet. The 30% of leaves are the ones highlighted. And so this method is basically doing the same thing. And we could, we could just make it 25% instead and call it the same thing. Leafs 25%. And now we've got that. And if we want to make more groups, we can make another group 5%. And now we've got the 5% group selected. And so yeah, I think you guys kind of get what's going on now. And so using this method, you could do it through attribute vops using this setup, or you can type in the wrangle, which is doing the same thing, but it's just an equation basically. That might seem a little more confusing. So if you don't like typing vex, you could always do it this way using nodes, and just the order of operations matters the same way that the order with the parentheses of operation matters here. And okay, cool. And so now you might be thinking, okay, now how do I apply this to our object? How do I shade this? So let's close that. And so we've got our material. So let's move back down here. And we'll just use the wrangle version. And I'll just keep this here. What's neat is you could actually save this and just, I could copy paste this for my other trees now. I don't have to rebuild it every single time, and it'll work. But oh, and the reason why we're getting a little error here is if we click this, you'll notice that basically there's attributes that are mismatched. So because we created our our leaves and our class attribute on this side, and they're not connected to the trunk and all the other geometry, and we merge them, it gives you an error because it doesn't know where class and leaves go. And so to just get rid of that error, if you need to get rid of it, is you just got to check at what attributes you need to get rid of. So class and leaves. So if we do a attribute and you pick or delete, here we go, attribute delete, and they're, if you check here, they're primitive attributes. So if we go to primitive and we select class and leaves, it's no longer giving you an error. And that's just because we don't need these attributes anymore. We only needed them for this stage to create our groups. Now that we've already got a way to make groups, we don't care about those attributes, and we can just trash them and get rid of them. And so, okay, now we're back to our material. And so what we could do is you would normally think, okay, I just got to make another group here and use the new let's actually save, use the new group we made. So we've got leaves 1%, 5%, 25%. And you think you could just, oh, I'll just add another group and I'll pick 1%. But what ends up happening is the groups conflict. And so due to the order of the object, they don't overlap correctly. So you actually don't want to do this. What you want to do is, so let's get rid of this, 7. So you want to make actually another material. And since Houdini works in the node order, basically what happens is the this second group is going to overlap this original shading group. And so here, let's just choose, we'll choose 5%. And so now we'll make a new material. And so let's actually go to our, or actually, faster yet is if we go to our leaves, select it. And so it's here, highlighted, leaf 1. And let's lower this down a little bit. And let's hold Alt and duplicate it. And we'll call this 5 PCT, which is 5%. I think that's what we just selected. Yeah, 5 PCT. And so now let's just apply that shader. So here it is, acacia tree leaf 5 PCT %. And so now it's added here. Let's select it. Let's go inside. So now we've got our leaf, and we can change this to look different. So let's say, I don't know. Let's and actually this is using a normal map. We should get rid of this because the normal map is old. So actually let's do that right now. Let's type in bump. The new if you guys don't know yet, the normal map is old. It's deprecated. You shouldn't use it anymore. The new way of doing things is using the bump map and just changing, instead of height field, you can change the object space or tangent space normals. And so let's delete that from here. and plug that in to our overall bump input. And let's get the same texture. Plug that in. And we'll just copy the location, paste. And now we can just delete this. And the reason why this is better also is it lets you control with the texture sampler the filtering, so the map bias, so you could lower this if you don't want the filtering to be as strong, and do other stuff with it that you couldn't normally before. And something to keep in mind if you're going to use bump map now, you need the new normal method. You have to make sure you turn on gamma override and have gamma at 1, because this doesn't do it for you automatically. So you gotta do that yourself. Okay, where were we? Let's turn that on too. Okay, so now we can adjust this. So let's make a color correct. Drop it in here. And we can change the color now to be something totally different. Or we could even change the texture. We could do whatever now. And so if we, let's save. Open up the render view. Right now, it's going to look the same because we haven't adjusted the color. But we'll start to notice a difference right now. And let's actually, let's turn on a LUT. And adjust that a little bit. Okay, cool. So right now, if we zoom in here, and let's undersample by 2. So if we look at it, there's no difference, but it's shading another group. So what we got to do now is actually change it. So if we adjust the hue, let's see, you can't see it too much yet. There we go. You'll notice if we zoom in here, these leaves are purple now. And so 5% of all our leaves in our scene are now this new shader group. And yeah, so this lets us now customize our leaves further. So there's a little more randomization going on. So for these, let's do yellow. It's not red. Something like this maybe. A little less saturation. Even less. A little less. Let's maybe drop the value. A little less contrast. Maybe bump up the gamma a bit. Cool. So now 5% of our leaves look like that. And actually, let's come in here and let's delete that. And let's duplicate this so the back side is even more desaturated. The bottom side, or not the bottom side, the translucency that we've got here. Let's use GGX. And cool. Now if we rotate around, look at it from a distance, we've got a little more variation in there of some of the browner leaves. Maybe they're still too saturated. Maybe we could desaturate further. And so that let us now make 5% of our leaves this brown. Maybe we want, let's pause that. Maybe we want another group. Maybe we want the, let's click on that, the 25% group. And so we'll come back over here. We'll duplicate this. We'll call this, oops, let's make this a little bigger, the 25%. And so we'll go back in here and we'll select our new 25%. Let's jump in here. Now if I press play, there's going to be a lot more of those brown leaves. Because it's using the same shader. As you can see, maybe 25% is a good number for those leaves. And so maybe let's see, let's adjust it. Now they're blue. Maybe a different kind of green. Let's increase the saturation. But maybe we'll make these darker. Maybe that's too dark, but you can see now that we've got these new leaves. And so now we've got darker leaves and lighter leaves. Mixed in. And so yeah, the idea is basically you could just keep on layering all you want. And so you might be thinking, okay, what happened to our brown leaves? And this is due to that problem that I mentioned earlier. So let's pause that. Where our group, now this 25% group is overriding our 5% group because they're not unique groups. They're sharing the same leaves because of the way we broke up the groups. We would actually have to make another one of these. Let's delete that. Plug that in. And now let's get rid of this 25% and only have the 5% here. And we'll get rid of the 5% here. Oops. $25, 5. So now we've got the 25% first, then we've got the 5% next. So now if we press play, we have our little brown leaves in there too. And this is just due to the way that this system works. Is basically the groups aren't overriding each other. They're using the same leaf chunk, and so you have to actually just lay them in order in the material stage, so that Houdini knows this set of materials comes first, then you're going to overlap it with this, and then you're going to overlap it with this. And so now, if we look at things, we've got our brown leaves, some of our darker green leaves somewhere in there. Of course, we could change the color on those. We can make those yellow. So now they're red. Let's go with the stick with the dark green. So yeah, that gives you, I think, guys, a good idea of what's going on here. Where now my leaves have variation of colors. They're not all the same color, the same green, the same yellow, and so on. We've got some lighter green, some darker green. And yeah, you get the picture, I think. Alright, guys. Well, I think that pretty much covers what's going on, how to do this using both attribute VOPs and an attribute wrangler, how to translate both the exact same things. So this kind of covers all that. Let's just a quick overview. If we come in here, we converted this vex code to do the same thing using these attribute VOPs. We use the connectivity SOP to create little groups for all of our leaves, which made the necessary primitive attribute class, which we then turned into leaves, which we then, using a group expression, controlled our groups by percentages, and then use that to then control which materials go onto which objects. So hopefully that gives you guys an idea of how to do this and how this applies to other trees. You could just copy paste that now and paste it into another tree, and it'll do the same thing. And this is a method to just give your leaves a little more variation so that they're not all the same, and break up the colors and stuff, which adds a little more realism when you're looking at the leaves in a nice, lit HDR or something. Like this is just a plain HDR, but if I were to change it to something like a nice sunny day, it would, it would look a lot better. And so yeah, this, as you can see, this, even though it's subtle, just a couple little extra brown leaves and different greens really help to sell the image. It gives things just a little more quality and realism to them. All right, guys. Thanks again for supporting my Patreon, and look forward to seeing any cool stuff you guys make and making new tutorials for you guys. Hopefully you guys can pick up the new version and check out the denoiser and all the other cool stuff, the Perlite AOVs that just came out. A lot of really cool stuff's coming down for Redshift. Hopefully CryptoMat arrives any week now. And once that comes out, I'll probably cover CryptoMat because that's really important to know, and how to put things together in Nuke using CryptoMat and Perlite AOVs. I'll probably go over that later. But yeah, thanks again, guys. Have a good one.